Can you hear me?
Yes, good afternoon.
Okay, good afternoon, everyone. Welcome to the grand finale presentation of the Harmony Data Science Internship for 2022 focus, brought to you by Harmony. My name is Ibo Success. I am a junior data scientist working at Harmony AI Lab. I'm joining you from Abuja, Nigeria, and it is a privilege to say I will be your host for this section. The mission of Harmony is and has always been to develop an army of problem solvers through specially organized internship styled training in data-centered careers. We pride ourselves as having been successful with this mission, and it gives us joy to have interns in the fall 2022 cohort perform machine learning wonders with various data sets from different domains, including weather, gender, health, sports, and so on. This is the second time in the cohort our interns have had the chance to work in cross-functional teams. The first was the premier project presentation, while today they will be presenting their capstone project presentation. They explored and analyzed, provided insights, built and deployed models, and are now ready to share their findings of the data set used with you. So moving on, I would like to especially welcome all members of the different data communities present here, Harmony Fellows and Harmony Internship alumni, and our incredible interns who have made it this far. I say well done and hearty congratulations to you for the great and excellence you have displayed so far. You know, it has not been easy, and yet you have gotten to this point. Well done. So without wasting much of your time, I would like to introduce our judges. So the first person we have on the list is Yodun Awojobi, who is a customer engineering manager at Google and an adjunct professor of cybersecurity at the University of Dallas, Texas, USA. Yodun is also a creative technology architect, cloud computing expert, and an amiable mentor. Hello, Yodun. Thank you for joining us here today.
Thank you very much, Mercy. Oh, Success, actually. Good morning, all.
So the second person we have is Charles Adetiloye, CEO and co-founder of Marvin Code, a US-based firm that builds scalable data and AI platforms for many of the world's largest companies. Charles has over a decade worth of experience in machine learning operations. Good to have you here join us today, Charles.
Thank you. Thank you, everyone.
So the third person on the list, we also have Wale Akifaderin, who is a data scientist at Amazon, an expert in machine learning, deep learning, statistical experimentation, and general information theory. He consults for startups in the data science and artificial intelligence space. The president of Wale, thank you so much for joining us here.
Thanks for the introduction. Yeah, excited to be here.
So at this point, I'm going to hand over to Daniel Ovalobi, my colleague, to take over from here.
Thank you, Success. All right, so my name is Daniel, just like you said, and I'll be moderating the presentation today. So just before we go into the presentations, please take note of the following. Each team will have only 7 minutes for their presentation. You will be the first cohort. You'll be the first cohort to have 7 minutes to present, as your predecessors only had 5 minutes. You'll be given a warning to round up at 6 minutes, 30 seconds mark, and muted once your 7 minutes is up. I think we heard what I just said now. If a team is not available for its presentation at its allocated time, that team will forfeit their presentation. Also, at the end of every presentation, we will hand over to our judges for their questions and comments. Feel free to use the comment section for your comments and contributions. And finally, dear presenters, try your best to be concise and straight to the point. Remember, you have just 7 minutes. Well, and now without further ado, we will now hand over the mic to our first set of presenters for the day. So, Team AWS, you now have the floor. Team AWS, please, are you there? Sorry, am I audible?
Yes, we are here.
All right, please share your screen.
Good everyone.
All right, your time starts now.
Alright. My name is Joshua. I am representing Team AWS on a project titled Fake Banknote Detection. I am not here alone, presenter, and should be taking it from there. Second presenter, please. You can start now.
All right. Greetings. Our project is focused on the detection of fake banknotes. Sorry.
Hello.
Can you please move the screen? Joshua?
Yeah, are you there?
Yeah, can you please move the screen?
All right. Can you see me? Can you see the finger there?
No, I can't see it from my side.
Oh. Let me just take it from there. All right. I said earlier, my name is Joshua Olawinde, and my second presenter is Emapasa, and the project lead, Jennifer, and the rest. So our program statement is this project is set to use supervised learning models, which involve classifier algorithm as a binary classifier that separates two classes to disclose features that could identify if a banknote is counterfeit or original. Our approach: data sourcing, data wrangling, data cleaning, experiential analysis, feature engineering, and predictive modeling. Now, to know but furthermore about the data set, our data set is it comprises of two major rules. 200 rules and 7 features. The features are counterfeit, which determine whether a note is unique or counterfeit, with 0 for unique and 1 for counterfeit. Length, the left, the right, bottom, top, and diagonal. Now, data sourcing. Our data is gotten from Cargo, and this is at the point of data wrangling. At this point, we discovered that our data has no non-values. That means no missing values. And we proceed to cleaning data and also to check for outliers. And during this process, we use statistical techniques to remove the outliers from our data set. As I've said earlier, we clean data. The data has no non-values measurement. That most of the unique nodes has a value from 114.2 to 54. While the fake notes has a value lesser than that. Then move straight to talk about the right measurement and the left measurement. Now, building and training the model. We employed several models to train and validate the data as we try to ensure that the data was not overfit. In the end of our training, we chose Iron Forest as the best performing model against others in terms of speed and accuracy. Here is the confusion matrix showing us that the model actually performed well with no errors. At the end, our accuracy score was 100% with precision and recall also to be what? 1 each. This is a stage of training where we and deploy our model for evaluation. And the parameter used here is that any banknotes which the parameters did not meet up with the ones the model predicted, it will either say the note is counterfeit or unique. These are limitations. In the limitations, we have what? Null values, and data set we used was very, very small. And the summary. By using the results, summarize that the data demonstrates some easy method of analysis. Simply employing diagonal variables has produced excellent classification results. Top and bottom are two excellent variables to include in predicting model in order to categorize counterfeit banknotes. Thank you very much.
Oh, wow. Thank you very much, Team AWS. That was very concise. So I'll now invite our judges. I'll invite Wally and Biodun to, but Wally first, please.
Okay. Thank you. I have a question. Do you guys have any example of an image of the banknotes? And what country the banknotes are from?
The banknotes is from Swiss
It's from where?
country.
Switzerland.
Swiss.
Okay.
Yes.
And do you have the image of the banknote? Anyway, no. Because I was just wondering if you have the image of what fake and original looks like. Okay. Yeah. Thanks for the presentation. So for me, I think my major issue with this project, I think I'll be honest and go straight to the point, is that a lot of what you guys are using or that you guys used for your analysis are actually the sort of the coordinates of the different banknotes, which is using distance features, right? Length, the left, the right, the bottom, the top coordinates, and then the length of the diagonal. And to be honest, I think people that are making fake banknotes, I think they're pretty much smarter than this, right? In terms of those features, it's just gonna be as accurate as the real one, right? Now, and the reason why I'm asking you about if you guys have pictures of the image is that I feel like it's much better to build a computer vision model, right? Which means the different pixelated properties of the banknotes that maybe an accurate computer vision model will be able to see and sort of check that granularity to determine if the banknote is actually fake or not, right? But if you notice from this, it seems the data set is perfect. So that's an issue that I have, because you have, when you tested it, you have like a 100% accuracy, 100% F1 score, right? The analysis methods are fine, but I just feel like this data is not a representative of what's out there in the real world, right? So for example, if I probably want to redo this, right, you could even do things around a computer vision model taking images of the new Naira notes, for example, and the old Naira notes, right? And try to see if you can differentiate between them, or if you can find fake notes, right? You can actually take the images and then you run your model on the images themselves and not on these sort of distance or length features that you're using. But overall, I think the analysis, the methodology and the modeling, they are fine because you have sort of tabular features. But I think the quality of solution analysis, you can actually improve these by going the computer vision route. So that's my comment. Thank you.
Thank you, Wally. Pierre, please, Wally.
Thanks. Well, great attempt with the project overall. My first question, I have two. The first one is, what were some of the challenges that you guys faced, and how did you overcome them?
The major challenges we faced was that the data set is very small, very limited, and for better prediction, for our model to work very well, we need more features. And as the first judge has said, we need to work on visualization way of detecting fake news and sort of fake banknotes. But with what we have in data sets, we only make use of what we have, which is the data set, and we were able to circumvent some of those events by removing outliers and also trying to check the diagonals and the heights to differentiate between the fake and the original notes.
Oh, I'll take the silence for yes.
Hello?
Yeah, the other comment is probably not more of a question, and this is probably a little bit more tangential to Wale's comment earlier. I would highly recommend that you, in your future iterations, you consider the use of AI in doing a lot of the work that you're doing. I mean, statistical method is fine, but it seems like AI would provide more accuracy. You know, like there are image models, there are a bunch of like computer vision models that you could be using that will do a lot of the statistical work that you guys are focused on right now. That will do it better. And you don't have to answer, but it will be, I'm curious to know what your next milestone or the next step from where you guys stop. And again, you don't have to answer. It's just a thought. Just think about what the next step should look like. Maybe it's using AI. Maybe it's something that you already have as a blueprint. Yeah. Overall, good job. Encourage you to continue forging ahead, but you might want to raise your bar much higher.
Yes, sir. Thank you.
Mhm.
All right, thank you, Biodun, for that very wonderful comment. Now, you can stop sharing your screen now. Thank you. I'll move on to the next team now. Team Beanstalk. Are you guys there? Team Beanstalk.
Yes, we're here.
Please share your screen. All right, Team Beanstalk, your time starts now. Your time has started, Team Beanstalk.
All right, good afternoon. My name is Stephen Isola. Our team worked on age and gender detection for Team Beanstalk for the Amoya capstone project. And this is the highlight of the members of the team, right from Ezile Inyagule to Stephen down to Enoch Adetunji. And excuse me. Next slide, please, Ezile. Our data set was obtained from Cargo. It's a UTK face image data set with total observation of over 23,005 features, ranging from age down to pixels. By way of methodology, we went from data cleaning down to, next slide, please. Okay, for our project objective, the very first on our objective was to gain insight on the data and then pre-process it down to modeling and testing of the models. Then for our methodology, we started by fetching the data sets from Kaggle. We cleaned it, visualized some of our samples. Then we came up with the models for the age and gender. And for our data distribution, we discovered that the two targets that are focused in this project, talking of age and gender, had distribution for age. It's ranged from age 1 to 116 years, while for gender, it's a mixture of the male and female genders. And then during the course of the project, we had to classify the age into 5 classes, as a way of feature engineering, because we considered it that it will be better for us to come up with a model that predicts the age range of our image samples. So that was why we came up with this, from the first range of 0 to 20, down to age range of 81 to 120. And the next slide actually showcases a sample of our data sets. These are the faces we have in the data set. So we just randomly picked 15 out of them, and this is what they look like. Going into the modeling, we came up with 2 models, one for age and the other one for gender. We used convolutional neural network, to develop our model, and it's a 3-layer CNN model, that was used for both the age and gender. And this shows the test results, from testing our model. We could see after evaluating the model, we discovered that we were able to achieve 80% accuracy for the age model, and that is why we have this result we are seeing. For the gender, we were able to achieve 90% accuracy in the predictions, for the gender model. And for the accuracy and loss curves, for the accuracy curves for both targets, we achieved an upscaling pattern of graphs, so which shows that our model learned correctly during the process of development. While for the loss curves for both age and gender, we could notice downward trends, to show that the error pattern reduced along the learning process. This shows the confusion matrix and the classification reports for our model. And it from the confusion matrix, you could see that 2,227 times our model predicted the male gender to be true. Likewise, it also predicted the male gender 2,071 times, as against the reverse diagonal numbers that we have here. So this shows that our model actually performed a bit better. And for the conclusion, from during the course of the project, we're able to discover that CNN is most effective in computer visualizations and for image recognitions. And we could see that there are applications of these models in crime detection, job interviews, victims identifications, and much more. So this is all we have. Thank you.
Thank you, Team Beanstalk. Okay, I'll now invite the judges, Biodun and Charles. But Biodun goes first.
Okay, great. I'll make my contributions quick and my comments quick. More comments, no questions per se. Great job overall. I'm glad that you're using models to analyze images. What's your next step?
Well, basically, our next step is looking at a way of having much more samples, because we discovered that the larger the number of samples we have, the better the accuracy of our models. We were given only 23,000 samples to work with, and that could have contributed to some of the deficiencies we achieved in the accuracy of our models, especially the age model. So we intend to have additional samples to do much more testing to see if we could achieve a greater result with much more accuracy.
Okay, that's a good next step. And from a model perspective, what other models are you planning to test out on the CNN?
Well, for now, we've considered CNN. We haven't actually thought of another model in particular, but one thing that is on our mind is to see how we can also apply CNN to natural language processing and other areas of artificial intelligence, to see how effective it can be in those other areas.
Okay. Well, my suggestion is you might want to consider writing or publishing something around what you've done and your journey and your next step, just so that there are folks out there in the data science world following some of the work that you're doing as a team. So
Okay,
there are
sir.
many sites where you can blog your ideas. You can use Medium. There are a whole bunch of them. Yeah, consider that as the next step, because it also helps you stay accountable to your readers as well.
All right, that's noted. Thank you so much.
Overall, good job.
Thank you.
Thank you very much, Biodun. Charles, do you have anything?
Yeah. Great job. I think this is a very impressive project, by the way. But one thing I'm really concerned about, especially for us minorities, is the ethics and the responsibility around using AI. If a human being is biased to you, you can still express yourself. But if an AI model is biased to you, I mean, good luck trying to figure it out. So in the process of doing this, one thing I noticed right off the bat is like your data set might not be evenly distributed or represents the various complexions, people, age, gender, and race. How do you make sure that there's no implicit bias introduced into your training model, so that if the model says a Black person is not thinking about it as a gorilla or something outrageous like that? And it's happened before in some of these data sets, because they're not normally distributed or evenly distributed across boards. So how do you solve that and make sure bias is not introduced in your data set from what you've done? I understand you took a public data set and things like that, but what do you think you can do to be more responsible in terms of what you do and what you build, and make sure it's not something that will create unnecessary fair advantage to a particular group or over the other?
All right. Thank you. So in response to your question, you are right that the data sets or the samples were not evenly distributed. And what we employed during the course of the work was to use grayscale images. We had to, before modeling, we had to use grayscale form of images, so
Yeah,
that
I don't think that would solve it as well because, I mean, Caucasians have long pointed nose. Most Black people of African descent, they have flat nose. So the features beyond just grayscale
Oh,
image that you want to take into account. I mean, it's if you're not looking at it right now, but it's something you want to look at down the road.
all
So
right.
whatever we're building, we want to make sure it's fair, just, and we're following the responsible ethics around it.
All right.
Because
Thank
if
you.
you train a model to be biased, it's a big deal.
All right. That's
All right.
noted. Thank you so much.
Yes, sir. A great job, though. I'll follow up with you guys on this.
All right. Thank you.
Thank you very much, Charles. You guys can stop presenting. Thank you. All right, so now we invite the next team, Team Elasticnet. Team Elasticnet, are you guys there? Team Elasticnet, please.
Yes, we are here.
Please share your screen.
Yes, sir. Yeah.
Can you please share your screen? All right, your time starts now. You can start presenting.
Hey everyone, my name is Nemat Ibrahim. I along represent in Elasticnet. We worked on epic prediction using machine learning. Is problem statement. To make a useful prediction, it is important to know the location where it will happen, when it will happen, how big the earthquake event will be. So far, no one can do that with certainty. Therefore, the goal is to make accurate predictions in real time or near real time, with the potential to provide early warnings to communities to be affected. And this project aims to study earthquakes and the behavior of earthquakes in a specific location, as well as to help prepare for future occurrences by predicting the futures, such as magnitude of future earthquakes. The existing solutions are lab-based prediction and progressive forecasting using deep learning methods, using earthquakes. Project flow.
You guys, we can barely hear you above your background noise. Your background noise is kind of impeding your presentation. Oh, I don't know what it is. Hello, can you hear me?
Can someone else in the group just take it up? I think your audio is bad. You might want to have your teammate take it up.
Okay, can you hear me now?
Okay, you still have that white noise on the background. Can your teammates take it up?
Okay, can you hear me now?
I think what is wrong is more electronic, but I mean, if no one else can take it up, you can continue.
Okay. Our data was sourced from Kaggle and it contains earthquake events from 1965 to 2016. It has 21 columns and 23,412 rows. So we moved to data cleaning, where the date and time columns were converted to the date time data type, and the invalid date format were manually corrected. Then the columns with high percentage of null values were also removed. Then we move to the exploratory data analysis, where we try to gain insights and understand trends in the data set. Then we move to clustering analysis, where we classify the earthquakes into groups based on properties common to each earthquake occurrence. Then we move to feature engineering and modeling, where we added some more features such as distance, year, month, weekday, and hour to make a more meaningful analysis. Then we train our models on the data set. Looking at these two slides, there are earthquake occurrence across latitude and across longitude. So we're able to deduce that there are more earthquakes around the equator, and the number of occurrences decreased towards the pole. And the eastern hemisphere recorded a great deal of earthquakes compared to the western hemisphere. And as shown in this map below, earthquakes occur where the tectonic plates that make up the earth cross meet and interact with each other. And many of these tectonic plate boundaries occur in the ocean, which explain why there are more earthquakes in the Oceania region, followed by Asia, South America, Africa, Europe, and North America. And looking at this graph, we're able to deduce that earthquake counts seem to be on the rise from 1970 to 2010. And this could be attributed to the increase in the number of seismic stations for measuring earthquake data over the years. Then we'll move to clustering analysis, where we use a 3D plot to represent the cluster. And we're also able to notice that the features that were associated with the division into clusters are the longitude and the depth. And the data set was divided into 3 clusters. The cluster 1, which is the blue color, represents earthquakes in the eastern hemisphere with depth below 300 kilometers. Cluster 2, which is the orange color, represents earthquakes in the western hemisphere with depth below 300 kilometers. And the cluster 3, which is a green color, represents earthquakes with depth above 300 kilometers in other locations. So my co-presenter will take over from here.
Hello?
I think it's having network issues. So we move to model building. We use the following features in predicting the earthquake magnitude: the latitude, the depth, the magnitude, type, distance, hour, date, month, and year. So these are the models that we use: the random forest, the gradient boosting, decision tree, and the cat-boost regressor. So we use MAE and RMSE to check our model's accuracy. And from there, we notice that cat-boost regressor performed best with an MAE score of 0.27, okay, and an RMSE score of 0.38. So we checked future importance for magnitude prediction for the random forest, and the months, hour, longitude, latitude, and depth are the most important features for predicting the magnitude for the random forest model. Then we also checked for our cat-boost model. The depth, year, longitude, latitude, and hour are the most important feature for predicting the magnitude. Now, during the course of our project, we were limited due to some certain reasons. The most important is that the data was not scientific enough, and it does not contain data about
You have less than 30 seconds left.
Seismic stations. Then our conclusion is our solution is capable of learning from past occurrences in different locations and times, and as well as describe how future occurrences should be. From our analysis also, we see that certain locations are more prone to earthquakes than the other. This will help us to take precaution and plan for any occurrences in the future. Thank you very much.
All right, thank you, Team Elasticnet, for that presentation. I'll now invite our judges, Charles and then Wally. Charles.
Yeah, this is very interesting. Although there was an audio glitch earlier, but very good presentation overall. So basically, you're looking at the historical data and you're figuring out the patterns of earthquakes over time. Is there any way you can forecast into the future based on what you're seeing and like identify areas of potential risk where there could be like earthquakes? This body of work is not covering that right now. Like you can say like, okay, on a scale of 9 to 10, 1 to 10, this place is more likely to be impacted.
Yeah, the data does not contain enough information to predict when earthquake will happen. It can only tell us the magnitude of future occurrences, but not exactly when the earthquake will happen.
No. Can you say that again? Sorry, the audio is a little bit bad.
Okay, I said the data was not scientific enough to be able to predict when earthquakes will happen. We could only predict the magnitude of next earthquake occurrences, but not exact time when the earthquakes will happen.
Okay, is there any way potentially looking at what you can do? Because I'm looking at it from the value creation perspective. most of the time you want to do like work
Yeah,
or
more data.
just properties and then to move on some areas that might ask for. Is there a way you can extend what you've done to basically cover that and talk more about that? Or you think it what?
It's possible. It's more data.
And what do you have?
Hello, I'd like to answer that question, please. Okay, so while we're checking around for data sets that could do this, we found out that it's a major problem. It's not it's a major problem in the geological world that they can't find scientific data that is scientific enough to predict the Earth's seismic activity. So most of what they get is data that has data they collect after the earthquakes happen.
Yeah. Well, yeah, that's what I'm trying to get at. Was like, is there like a pattern to this so that over time? Because if I can have a knowledge of all the things that have happened historically, I should be able to forecast into the future based on what I know in the past.
Yes. While we look through the patterns through most of the data that we get, I'm not talking about this one that we've worked on, like a general issue now. It has been said that most of the features that they look forward to, some of them failed them at some point. So at right now, earthquakes are mostly unpredictable. Earthquakes are mostly unpredictable. I think the latest research
You think it's you think it's a random occurrence?
Pretty much a random occurrence for now. I think the closest answer to that is an article I saw that we need to take some satellite data about the atmosphere, about the lithosphere, about some data that has to be taken deep into the earth crust, which most of the method of getting this data are expensive, so they can't reach that for now.
Okay. Yeah, thanks a lot. I think yeah, this is impressive, but I think there's still a lot more work to be done so that we can make it relevant. But like Abiodun said earlier, um, basically expanding on what you've done and publishing it out there would be a good place to go so that you can get feedback from more people and things like that. Because there are a lot more features that you can use to like predict if there's going to be an earthquake or not, some animal behaviors, because animals sometimes they pick up all these signals that humans don't pick. And there's some research where they have animals sensing the likelihood of an earthquake in a particular area, and they move ahead or migrates before the earthquake strikes. So things like that, or you don't start back in a few minutes before the earthquake occurs. So they must be picking up some signals that we're not picking, or our sensors are not smart enough to pick. So it's not a random occurrence if I would say that. The question is like, how can we identify all the features that will tell us if something is going to happen or not? I mean, like a dog barking it's very well recorded that few minutes or hours before the earthquake, you start hearing all dogs barking and things like that. They probably sense something that we're not picking up. And the question is like, how can we build a model or have sensors that can pick up the kind of data?
Okay, sir.
Thank you.
Thank you, Charles, for that comment. Wale.
Yeah, Team Elasticnet. Thanks for the presentation. I have a few points. First, I think the title should be changed to earthquake magnitude prediction because when you put it as earthquake magnitude, like Bjorn said, it sort of it looks like you're positioning the work as you sort of predicting, when next there's going to be an earthquake. But what you're actually predicting is that if there's going to be an earthquake, this is what the magnitude would look like. And then there's a question around, do you know, are earthquakes random occurrences or not? I think your analysis actually answered some of the questions, and I really like where you had the the feature importance, because you would see that some of the things that actually contribute to your model the most are things around the depth, the longitude, the latitude, and things like that. For example, look at the earthquake in Turkey, right? So historically, they've always had earthquakes, right? And so those are some of the things sometimes that would predict that, yeah, they're prone to earthquake. Maybe you don't know the time, but sometimes you can use these features to know, oh yeah, there will be earthquake at some point. And it can also help you know what the magnitude would be. So that's awesome. The other thing that I also noted is that, I mean, the project can obviously be improved by using sort of additional seismic activities. I think there are some open source data set where they stream seismic activities from some of these longitudes and latitude, some of the geographical location real time. So I think that can improve the project a lot. And then analyzing aftershocks. So that's one thing I was thinking of, that because, for example, Turkey had a 7.5 magnitude earthquake about a month ago, thereabout. Then 2 weeks later, they had another aftershock of about 5.6 or 6.5 magnitude. So doing more exploratory analysis on aftershocks for each, you can take your data and slice it and say, if there's an earthquake where the magnitude is higher than 7.0, for example, what's the probability that there's going to be an aftershock in the next 4 weeks? And what will the range of those magnitudes looks like? So there are a lot of exciting things that can be done already. I'm already excited about the project, and I think you guys can sort of do more exciting stuff to improve the project. And yeah, I agree. You should definitely publish it. Yeah. Thank you.
Thank you, sir.
Thank you very much, Wally, for that comment. Thank you, team Elasticnet. You can stop sharing your screen. The next team is team Fast AI. Are you guys there?
Yeah, we're here. Am I audible?
Please share your. Yeah, you're audible. Share your screen.
Yeah, just a second.
All right, team Fast AI. The time start now.
So yeah, hey, a very good evening, everyone. This is Team Fast AI, and we did a project on customer personality analysis. So this is our team. I am Harsh Pant, and I'm accompanied today by my teammate Edwin. So yeah, for a brief overview of the project, like what is customer personality analysis? So customer personality analysis is a detailed analysis of a company's ideal customers. So customer personality analysis helps the business to modify its product based on its target customer from different types of customer segments. So now what can we derive the problem statement out of the overview? So as stated in the overview, customer personality analysis is just a detailed analysis of its ideal customers. So we wanted to develop a customer personality analysis model that can accurately predict the personality traits of the customers and segment them into different groups based on the personality characteristics. So while we were solving the problems, we came across a lot of existing solutions, which included classification-based models and ensemble learning-based models, and then cluster analysis and customer ranking is k-means clustering. For our approach, we decided to solve this as a clustering problem as well. And for a smooth working of the team, we decided to make this a step-by-step process. The steps included data sourcing, EDA, exploratory data analysis, feature engineering, model training, and model deployment. For the first step, that was data sourcing, we gathered a data set from Kaggle, a data set of customer personality analysis. So now for the second step, that was EDA, exploratory analysis. We came to a conclusion that our data contains over 2,240 observations and 29 features. We also handled null and missing values, and we concluded that there were missing values only in the income column, representing 1.1% of all the captured income. We also fixed some data types. For example, date customer was initially classified as an object data type, but we converted it into a date time data type. So yeah, we also dropped some columns. For example, ID column was dropped as it has no correlation to any feature in dataset. And so yeah, for the next step was feature engineering. The following slides show that there were outliers in the dataset. In income column, we also handled the outliers, and this is the data visualization. For example, this cat plot shows whether the parent relation with the income. So yeah, and this bar chart shows the proportion of income, age, and total purchase of customers grouped by the level of education. So yeah, now for the next step, that was feature engineering. We calculate the age of customers from customers' birth year by subtracting date customer column from 2014. We created columns like family size and parents to represent the number of people in a family and if a customer is parent. We also created a postgraduate column from the education column using following classification: master and PhD as one and 0 for undergraduate and basic. So now for the next part, that is modeling, I would like Edwin to continue.
Thank you, Harsh, for the modeling based on the problem. Based on the modeling that we are, the problem that we are handling, being clustering, there are several algorithms in machine learning that handle clustering. There is k-means, clusters, and agglomerating the models. We had to clean the data set to use label encoder to convert them into numerical values. Some of the features of the dataset were transformed into using standard pre-processing techniques so that they have a zero mean and unit variance. Lastly, we were able to use elbow metrics to determine the number of clusters, and to perform dimensionality reduction, we used PCA. In terms of using the elbow method, we found that there were 4 clusters that were able to be found. And the best model that we used was agglomerative clustering using 4 clusters. In terms of categorizing our customers, based on the 4 clusters, we've identified they were categorized into low spenders, high spenders, average spenders, and minimal spenders. In terms of deploying our model, we used Power BI, and we were able to come up with a visualization, as you're seeing on the screen. We're able to delve into the customer traits based on the clusters. We found that cluster 1 was based on people who earn a little and spend a little. They had 0 or more kids, mostly married people, and they were between the age range of 30 to 68. When it came to cluster 2, people who earn the highest and spend the highest had no kids at home and had no teens at home and were of the age between 19 to 73, and they have the highest total purchase. Cluster 3 were people who earn high, spend high. They fall into the postgraduate category in terms of the educational level, and their family size is of between 2 to 4. The age range is 24 years old to 67. Cluster 4, these are people who earn the lowest and spend the lowest. They have no teens at home. They are the least total purchase and mostly have 1 child at home. In answering business questions, in terms of the characteristics of our customers, mostly are married, mostly don't have kids, they're educated, and majority are of the middle age between 33 to 68 and earning an average between $15,000 to $98,000. In terms of the shopping habits, they spend more on wine and meat products based on the data set in the last 2 years, and majority were able purchased through in-store and web purchase. Customer without kids spend more. In terms of the products that need more promotions, products such as sweet potatoes, fish products, and fruits need more promotions. However, gold, since it's of low purchase and it's based on the customers.
You have 1 minute left.
In terms of the marketing to be made more effective, there are discounts to drive it to the web purchases. In conclusion, the clustering analysis provided valuable insights and based on the 4 distinct groups that we found and the challenges that we are able to encounter in terms of based on our geographical differences is setting up meetings. In terms of recommendation, we recommend using alternative clustering algorithms and also incorporating more data. In terms of contribution to the business value, customer segmentation, improved marketing strategy, customer satisfaction, and data-driven decision-making are some of the advantages using clustering. We gave important links such as to our repo and also the Power BI visualization that we are able to come up with. Thank you.
Thank you, Team FastAI. That was a very wonderful presentation. I will now invite our judges, Biodun and Charles. Biodun.
Yeah, thank you. Great project. I'm very inspired by the work that you all are doing, specifically because I see the application of this for mainly small businesses. You can think about companies like Amazon and companies and large retailers like and wholesalers too will have more sophisticated models like this. What I'll ask for you all to consider is see how you could put something out there, not only in writing, but put something out there that makes this easily digestible by small, medium businesses like shops that don't already collect this type of data, or make it easy for them to use this type of information and drive some business outcomes. Because let's be frank, Amazon will not be using what you just created. They'll have sophisticated AI ML models. They'll have optimized models that are looking at data beyond all what you're recommending right now. If we're looking to target your current work to small medium businesses, which I think, at least I would like to suggest that that's probably where it fits with the most. It would be nice to consider additional data points. I know that's one of like the first steps that you all are looking to do. Consider demographics, consider seasonality, not only seasonality of the time when customers go purchase specific items, but seasonality for products as well. And there are many other ways that you can slice and dice seasonality. The other area that I would recommend that you all consider too as you're trying to scope down how applicable the work that you have done is geography. Look at like, how does this model, how does it fit into the Indian market, or how does it fit into the African market? Is it Ghana, Nigeria, Kenya, wherever, such that you're giving your audience or users something for them to take and go make valuable use of. And who knows, what you're doing right now could turn out to be a company in of itself, because you're empowering a lot of folks that have been forgotten. And let me see, I have one more thing that I've written here. Yeah, overall, great project. Great project. And let me know if there's any way that any of us can help. But I know for sure that both Charles and Wale are probably itching to make comments here too. So I'll let Charles speak next.
Thanks, Vita. Yeah, I think this is a very interesting project in that it has a very much practical application. Like most business, they're like a lot, man, every business is data driven right now, if you want, believe it or not. Some people still are not using the data well, but for companies using data, like Google, Facebook, they basically try to drive as much value out of the data they get in as much as possible. So the question I have is like, if I have a business, I'll have a bunch of KPIs that I define. If I define my KPIs and hand it over to you, will it be possible for you to use it in your system to like create this kind of models and get things out? Like, what will be the input to these systems? Because if I have a business owner, I don't understand data, I don't understand technology, but I have my key performance indicators. I want to improve customer satisfaction. I want to reduce their wait time. I want to make sure they're happy right after every interaction with the business. What will be my inputs for you if I have a business that I'm trying to build up and I have all these KPI metrics? I don't understand data science. Just to like piggyback on what Bill said. You there?
Hello?
Yeah, sorry, can you speak again?
Yeah. So I said, if I have a business and I have a set of KPIs and I give you all those KPIs as my inputs, How will you model and build things out based on what you just explained?
So if you handle this API, right? So I think we will try to integrate that data set and we can explore the data, like the data that you have provided us. Like, does that answer your question?
Probably not, but don't worry about it. I can follow up with you guys about on that. So basically, most businesses they have key performance indicators, not API. You're mixing it up. So a business owner that owns a bakery shop doesn't really understand what data is, but they can quantitatively measure things from their KPIs, and they're like, okay, I'm selling more today. There's a reason for that. More customer came in today, and you collect all those data. So I'm trying to understand how you analyze that data based on what you've done. Because if you want to scale this out and make it into something that multiple businesses can use, you should have a template, a playbook where somebody comes in with their KPI metrics, and you can apply your algorithm or your process to help them scale things out and point out areas where they need to improve, what they're doing well, and things like that. That's how you make it a production app that businesses can use. So I was just thinking of it in terms of that. So, but overall, good job. But I'll follow up with you guys for more questions around this.
All right, thank you.
Okay. Hello, can you guys hear me? Am I audible, please?
Yeah. Yes, you are.
Hello?
Yeah, you're audible. Yes, you can hear you, Daniel. Okay, let me just move on from that. I'm guessing that is having network issues. Okay, thank you, team. Fast AI, you can start sharing your screen now. And now we'll move on to the next group. That's team MLflow. That's Kenneth and Omar. Are you here?
Yes, yes, sir, we're here.
Thank you. Can start sharing your screen.
Okay. I will.
The time starts now.
Okay. Hello, everyone. My name is Omar. I'm going to be presenting today for MLflow team, for our team, I mean. Our project would be on skin cancer classification using AI. So I'm going to talk a bit about skin cancer. It's basically an abnormal growth of skin cells, usually caused by sun harmful rays. And if diagnosed early, it can be treated successfully with surgical procedures. So we had, there's these three causes actually to for this idea. Since the clinical examination are expensive and it does require training and efforts and time, and since almost everyone has mobile smartphones with high resolution cameras, and AI technologies are becoming smarter and faster and relatively cheap and easier to use. So we can use artificial intelligence to detect skin cancer in that situation. Our main aim of the project is to be able to classify skin cancer cell types from the other skin cancer types. Our approach for this to reach that aim, to reach that goal, first we imported the data set needed and the libraries, and then we created training and validation test splits. And then we did for the modeling part, we used convolutional neural network. We did train the model, evaluate the model. We did some hyperparameter tuning, and finally for the model deployment. So our data set consists of around 2,300 images with 9 different classes, skin cancer classes here. For the as we said earlier, the the libraries that we're going to use is mainly TensorFlow, Matplotlib, and Mathlib and Pandas. We started with creating the training and validation test validation sets. We use image dataset from directory. It's from TensorFlow, and as you can see here, we have around 2,000 images with 9 classes, and we use 80 to 20 training validation splits. The next step would be creating the model. At first, we didn't use any data augmentation. We did rescale the images to be in a range from 0 to 1. And then we started with convolutional neural networks and then max pooling, convolutional neural network, convolutional layer, and then max pooling, etc. And when we did for the compiling and model training, we use Adam as a optimizer and the loss as sparse categorical cross entropy. And as you can see here, we got a validation accuracy of around 54%, which is pretty low. And when we check the graphs, the accuracy and the loss graphs, we can see that the model did overfit. And the next step would be to check for data imbalance and apply data image augmentation. As you can see here, the classes are not, the data is unbalanced, and the next step would be balancing it using augmenter library. As you can see here, we did some rotation on the random rotation on the images, and we made 2,000 images per class. So in the end, we're gonna have 18,000 images instead of 2,000 images. We did the same thing again. We created training and validation sets, and now you can see we have 18,000 images instead. The model was the same, but we added one more thing, is we added the dropout layer in here. Also, we trained it again, and the validation accuracy got increased to 90%, which is much better than before. And if we check the graphs now, it is much better. It might be overfitting, but we will see on the model validation evaluation. Sorry. This is the hyperparameter tuning part, and I use like 40 trials, but not much improvement have seen. It's still 90% validation accuracy in here. For the model evaluation, it was 44%, even though the validation accuracy score was high, but the model performed poorly on the test set. That means that it is still overfitting. On the other part, for the model deployment, we started working on the model application, Streamlit application. We thought that we're gonna get much better accuracy, but unfortunately, 44% is not sufficient for us to deploy it online. So for the conclusions and recommendation that we got, we were able to get a model with 44% accuracy, and the thing is, data augmentation does not compensate for insufficient data. The recommendation that would be we might need more images from to get better accuracy and to help resolve the overfitting issue. And also we may do more parameter tuning, and or maybe we can do a deeper neural network in that situation to get better accuracy. Thank you. Thank you everyone for listening. And if you have any questions, please feel free to reach out.
Okay, thank you very much for that presentation. Over to the judges now, Wale and Biodun, or Wale first. Do you have any comments?
Yes. Thanks for the presentation. I enjoyed it. I have a few questions. When you had imbalance in some of your stemming from some of your minority classes in data set. And then you did augmentation using Augmentor. And so the first thing is I saw that the only augmentation that you guys did is rotation, right? So just mostly rotating the images by 15 degrees right and left. But I think the Augmentor library actually gives you more. And so an improvement would be to maybe try to use different augmentation procedures. So there are things around where you can actually change the resolution, you can maybe grayscale, you can move things around. You know, just more options beyond rotation. So I think maybe that would improve the model a little bit. I'm not sure, but you can always try.
Well, we did use random flipping here and random rotation, random zoom, but it was a layer. It's like, as you can see here, it's from pre-processing random flip, then random rotation. But we might add more, as you mentioned.
Yeah, because the things that you can add, like Gaussian noise, for example, to change some of the properties of the pixel. So I don't know, maybe that would work. My other comment also that I see is that you guys, you augmented the training data and then you also augmented the validation sets. And I think, I don't think that's the right way to go. And the reason is because when you do that, when you augment both the training and the validation, your results from the validation sets will actually give you a sense that, oh, maybe this model is doing well, right? So, but it's nice that you guys tested on like the set out test data, and you could see that, you know, you didn't really get an improvement. But if you didn't augment the validation set, you would have seen it, the performance and validation set, and I know that you're overfitting. So, but I think a lot of the overfitting would be, you know, try to put things like, you know, early stopping. Maybe you need to change some of your dropout rates, things that you can play around to check. But overall, I like, you know, like I mentioned, I like the detailed approach that you guys, and it's very practical. I would love to see this in maybe a blog post or something. So thank you.
Thank you. We actually did posted a Medium article on this.
Okay, great.
Yeah.
Awesome. Thank you.
Thank you for the feedback.
Okay,
yeah, great work overall. Means just skin cancer prediction generally. I'm curious to know from the sample that you all had, how many skin tone types did you use? Did you get that level of granularity? I don't know if I picked that in your presentation.
We had in total 2,300 images, and there was 9 types of skin cancer. But if you're talking about the skin tone, I think mostly it is mostly Caucasians, because it does skin cancer does affect Caucasians more than other skin tones. If that's your question, if I made it clear to you.
Yes, that was my question. Yeah, and that's really where I was leaning into, because there is a disproportionate amount of like Caucasians with skin cancer compared to other skin tones. But overall, great work. I would like for you all to continue doing this and hopefully see how the AI ML models that could complement what you're doing currently, like the newer ones. And there's a lot that's going to be coming out in this space. I'll recommend that you get plugged into a lot of the research that Google is doing with the DeepMind, and the other subsidiaries of Alphabet. There's so much work that you could use to complement what you're currently doing. So great work overall.
Thank you. Thank you for your feedback. Thank you very much.
Okay, thank you very much, Biodun and Wally. Okay, you can stop sharing your screen now. Moving on to the next team, Team Plotly. We have UDG and Hashit. Are you here?
Yes, I'm here. Can you hear me?
Yeah, we can hear you. Start sharing your screen.
Is my screen
Okay.
visible?
Yeah, it's on. Your time starts now.
Yeah. So, hello everyone. This is Team Plotly, and I am Hashit Saini. We will be talking about our model predicting the future of the US birth rates. As you can see, this is our team, our project lead, assistant project lead, QA analyst, and the team members who were the most active in the model making. The presenters are me, myself, and my co-presenters are team lead, Borotito Ayodhya. Now, about the introduction. So basically, there are many research and demographers who rely on historical data and statistical models to predict future events. So our model was similar to it. We wanted to predict the future birth rates in the United States. Now, the problem state was the birth rate in the US has been declining steadily in the recent decades. We wanted to analyze the past data of birth rates to see if we can find the reason for it and analyze what will be the future birth rates in the United States. So we sourced the data from this Kaggle link. It was an open source data. We basically got two data files of the US birth rate from 1994 to 2003, and the second was from 2000 to 2014. Now, our approach was we investigated the data and see what kind of models will fit best on the data. So we had two data sets, so we had to combine them. And for that, we first did a cursory analysis on the data to see if it was properly cleaned or not. And we found that almost all values were clean. It was a properly pre-cleaned data. After that, so we first, after doing the data analysis, we use different models to compare their accuracy and if the results match all the models. After that, we discussed the ramifications of the predictions for the future population of the United States. After that, we provided recommendations of where that model can be used. So the data preparation, as discussed beforehand, we had to merge both the data sets. So for that, after we basically converted it to a pandas data frame, and after merging it, we were having basically we were having a common area between 2000 to 2003. So we had to average out that value. After that, we used the resample method to take the mean of the monthly birth rates, as the data set itself was very huge, and using data analysis it was hard, and the monthly mean would do for our analysis. After that, we did a number of plots to understand the data. The first is a time series plot. We can see from 1994 to 2014 there was a steady increase in birth rates beforehand, but it decreased steeply after around 2005 to 2006. Then we did a box plot analysis to know about the average birth rates by year and weekly. As you can see, there is a seasonality pattern in the birth rates. The birth rates increase around the July-August months of the year. And in the weekly box plot, we can see that the birth rates are higher on weekdays than weekends. Then we decompose the data into trend, seasonal, and residual. As discussed before, there was a gradual increase in birth rates till 2006 to 2007. After that, there was a gradual decline in the birth rate. In the seasonality, we can see there is always a gradual increase in the birth rates and the decline per year. And this is the residual plot. So based on our plotting and data analysis, we chose two models for a plot for our data set. It is the autoregressive integrated moving average, commonly known as ARIMA model, and the FP profit model. First, we made the ARIMA model. In that, we use the auto ARIMA model so that we don't have to determine the parameters P, D, and Q ourselves. It would be determined themselves. So after inputting our values, the order of the ARIMA model was 12.1Q for PDQ, which was determined automatically by the after that. As you can see, these were the results, and we saw our model. After that, we plotted our model. So the result was that we used 95% confidence interval so to account for the invariance in the data set. But as you can see, it wasn't really the best model, and we couldn't really get the best result out of it. So after that, we used the FB profit model. So it is basically used for business time series analysis, and we believe that it would be much better for our data set. After that, we used the FB profit and assigned a variable called my model for our model. After that, we set the interval width to 0.95 to control the size of uncertainty in the predicted values. So the resulting object contained the learned parameters and trends which we got after applying it. As you can see, we plotted the model after 2014. You can see it's a general trend. It's similar to our seasonality plotting that we saw, and it's the unpredicted variance in this. Then we plotted the different components of the profit model. You can, as you can see, this is the trend. It's similar to our plot before. After that, we can see the weekly component. There is a gradual increase in the weekdays and decline in the weekends. And in the yearly component, we can see the seasonal component. There is an increase around July, August, and September in the birth rates. After the conclusion, we analyzed both the ARIMA and profit models, and both models show a gradual increase in birth rate over time, and there was a clear seasonality pattern in both models. After that, we both profit and ARIMA predicted a seasonality pattern in the model and a gradual increase in birth. So after that, we discussed what will be the possible benefits of this prediction. So we saw it can help in policy making. Forecasting can help in making policy related to if there is a specific decline at a specific time of the year. So there can be a policy to increase birth rates. After that, there can be business planning. Many businesses can profit from learning when will the birth rates will increase, so that some products related to that can come out at that time of the year, and organization can work efficiently according to that. For example, we took the hospitals example. When the birth rates will increase at a specific time of the year, they can be prepared for the increased birth and include all the equipments for the births, etc. And that concludes our presentation.
Okay, thank you very much for that presentation. We move over to the judges, Mr. Charles and Wally. Do you have any comments?
Yeah, I think this is very interesting, but I have questions more than comment. Does this forecasting takes into cognizance the changing socioeconomic factors over the years, like the years where there were recessions? During economic hardship, people tend to hold off things like starting a family or having a baby and things like that.
Yeah, the model itself doesn't take that into consideration, but when we analyze the model, as you can see in our trends, as you can see, there was a gradual incline in birth rates till 2007 and 8, and as most of us would have known, there was that.
If you stay on your model, in 2008 there was a recession. So
yeah, the model tells us that there was a gradual decline after the recession. So yeah, we can conclude that it was because of the recession due to the socio-economic factors, but the model itself doesn't take into consideration. It can be seen as we can analyze the result based on that, but the model itself didn't took into consideration the social economic factor.
Okay. What about things like demographic shifts, like population changes in the US, where things change due to immigration patterns, changing immigration laws? Do you see effect of that in this?
Yeah, no, our data set only included the birth rates and not the policy changes.
So, okay, what about like unforeseen events like COVID in 2020? Was your model
No. Our model was till 2014, and after that, it was basically a prediction. And I believe COVID itself was an outsider factor. It's not really natural in that sense. So yeah, our model failed to determine any. It was we can conclude COVID as a disaster. So yeah, it
Okay.
couldn't really determine that. Yes.
Cool. Great job. Yeah.
Yes.
Wally, do you have any questions?
Actually, I think you took the comment the out of my mouth. That was what I wanted to mention, is of considering, different socio-economic and social demographic factors, right? Things around maybe migration, for example, to the US. Can we sort of have, correlation between the years that has like the highest number of people immigrating to the US, for example, and the birth rate, and then of course outliers like COVID. So I think this can easily turn from a univariate forecasting problem to a multivariate forecasting problem with sort of
Yeah,
more
actually
data sets.
the model can supplement these factors. We can analyze the factors based on this model, but this model itself is not enough to account for all these values. So yeah, multivariate model would be much better.
Yeah, but I like how detailed the methodologies from the classic ARIMA methods to Facebook Prophet. So yeah, nice job, guys.
Okay, thank you.
Okay, thank you, Mr. Wale and Mr. Charles, for that nice comments and questions. Okay, now moving on to the next team PyCarrots. We have Joshua and MLflow. Are you here? Team PyCarrots.
Yes, I'm here.
Okay. Yeah, 10 seconds to start sharing the screen. All right, so time starts now.
I'm representing for Team PyCarrots, and our project was on the currency foreign exchange rates prediction. And these are my team members. Our outline goes through this. So an exchange rate is the rate at which one currency will be exchanged for another currency, and it reflects the relative value of one currency to another and depends on various factors. In our modern world, exchange rates of the most successful countries tend to be floating, and this depends on the supply and demand forces. And our objectives were oriented towards forecasting the closing exchange rate of any chosen currency pair. We performed time series analysis using the ARIMA and also built the Prophet model. Then we built a dashboard to see our findings and also calculate the converted exchange rate of each currency. Our project workflow went through the data collection to wrangling, stationarity analysis, model selection, and then model deployment. We obtained our data from Kaggle. We had a total of 1.4 million data rows and 7 features. The slot feature contained the currency pair, and currency 1, we found that were about 7 unique currencies, and currency 2 had about 113 possible currencies, which could correlate to any of the currency 1 pair. Then the date, then we had the open, high, close, low, and close values, and then currency 2, which refers to currency 2 in the slot feature. This also describes that. The time period of the data set ranges from the 30th of October 1996 for Australian dollars and Argentinian pesos to 30th of August 2021 for US dollars and Zambian kwacha. However, we found out that the eventual time frame series varies for each selected slug pair, which can be seen on our visualization later. On data wrangling, we converted the date feature to datetime format. We check for missing values. We also check for outliers. Then the chosen currency pair for this presentation was the USD and the Indian rupees. The data set was downsampled to weekly records and also forward for using mean. Our resample weekly data set contained about 927 rows and 4 features, as you can see. So we built in with an inbuilt function, you can choose your currency 1 out of the 7 possible currencies, and then currency B that correlates to that currency. On stationarity analysis for the USD INR pair, we saw that there's an increasing trend. And then on data decomposition, we can also see that there's also the seasonality component. And then to confirm the stationarity using the augmented Dickey-Fuller test, we can see that the data is non-stationary. Then to deal with that, we did a long transformation for our data. Then we built our model. We used these two models, the ARIMA model and the Prophet model, split our data into 10% test data and 90% training data. Using the ARIMA model, we first used an auto ARIMA to select the optimal values for the P, D, and Q, which was then used to build the ARIMA model, as you can see here. Then we checked out evaluation metrics, the mean squared error, mean absolute error, root mean squared error, and the mean absolute percentage error were within acceptable ranges. We also did the same with the Prophet model to make our predictions and also got the evaluation metric within acceptable ranges. Well, for model evaluation, we checked for different currency pairs as random, and on this specific day, which was 23rd of February, we checked the actual and the forecasted values by our model. Then on discussion, we found that currency exchange rates and financial may depend on other external factors which were not adequately captured in the data set, as we only got the historical data for the close prices. So we saw that for the chosen currency pair of USD CAD and which had the least error margin, and the USD Chinese yuan had the highest error margin. And this was shown in the fact that for the USD CAD pair, there has been a stable trend over the years, so it was easy for the model to forecast the close values. But for the USD Chinese yuan pair, we saw that there have been highly fluctuating factors which has made the predictions a bit with a high error margin. Our model was deployed on Streamlit, and we'll be seeing that here. So yes, for here, we selected our currency pair using USD CAD. The forecasted price today is 1.3619, and then we'll be checking that on Streamlit. So we'll check for USD CAD here. So this shows us we can see the visualization here for the USD CAD pair. And as you can see, for the forecasted price today is 1.3619 on Google Finance. And we can check the USD CAD pair is 1.324, as you can see by our model. So on feature scope and recommendation, we saw that data sheet collected for the last 2 years, as the last data point was about in 2021. And we also saw that the model can also be improved to help businesses and investors and central banks make their planning, forecasting, and other informed investment decisions. Limitations: data set has not contained data for the past 2 years. Project has not taken into consideration the effects of change in one currency pair on another, and also did not capture data about external factors, as we have shown. On conclusion, there are several factors that can impact the performance of the model, as we have seen, and it's therefore important to consider the context of the problem with the consideration of factors involved, stakeholders, and the requirements when building our models. Thank you very much.
Thank you very much, Bakari. That was a very wonderful presentation. Okay, now moving on to our judges, Mr. Biodun and Charles. Do you have a question?
Yeah, no questions really. This was really, really good. I mean, I'm surprised you did not factor Nigeria into it and predict Nigerian currency fluctuations and all that. The Was there a reason you didn't do that, or you just wanted to make sure your data is consistent?
There was no reason for that, actually. We just chose at random for different currency pairs. But then to also show, yes.
I'm going to try to believe that. Yeah. Overall, it's a good work. I would love to see what you all are considering and thinking about when it comes to ingesting additional data sources. As you know, currency fluctuations, especially in like countries like Nigeria, is a factor of multiple things, especially when you're thinking about like market forces, supply and demand, and how can you truly predict how the currency will fluctuate based on like multiple reasons. I'll be curious also to know how especially when you consider Russia-Ukraine war that's happening, how is your model working with regards to that? Because there's so many other things that could be inferred with, everyone would expect that rupee would have fallen to the lowest. Everyone would have inferred that cryptocurrency will have risen. So think about cryptocurrency as it relates to your project, and this is the beginnings of in my opinion, something that a hedge fund might want to use. So there's a lot of promise to what you're doing for sure. But yeah, I'm going to stop at think about cryptocurrency as you're thinking about this. Think about how the value and all of that. Overall,
Right. Thank you very much.
Yeah. I think Bjorn nailed a lot of questions I was going to ask, but I'll just continue from where it stopped. Like, when you're doing all these analysis, you take into consideration things like the macroeconomic factors of a country, because that determines a lot about what their currency value will trade for. Like, if the macroeconomy is good, things like interest rates, inflation, and GDP, you can predict how it's an indicator of how strong a particular country's currency will be. So do you take that into consideration when you're building this, or you're just basing all your analysis on the data that you have at hand?
We based our analysis based on the data, the historical data sets. We only had the open, high, low, close values, which we initially saw were highly correlated to each other, but we focused on the close values. So we also went ahead to also investigate how economic factors could have affected by comparing the USD CAD pair with the USD Chinese yuan pair, and we noticed the effect of factors that happened in Beijing, making their currency exchange rates to fluctuate like a lot, so which really affected the forecasting of the model, as opposed to USD and Canadian dollars, which have had a somewhat stable trend over the past few years, so which have made forecasting much easier. But I really think that by also incorporating all these external factors, as you've mentioned, the micro and macroeconomic implications as well, would also impact how the model will be able to make accurate forecasts. Thank you.
And do you, just like to that, do you, in your forecast, do you have a lead time? Mainly, if I know it will be okay for me to know like 6 months from now, or maybe 3 weeks from now, what's the average lead time that I can know that, okay, things are going to change based on the indicators I'm having right now? Because if you're forecasting into the future, you need to have enough lead time to prepare or adjust things. If you're like a private, if you're like an investment firm, things are going to go bad in like 6 months, you want to adjust before then. So what's the average lead time for your forecast into the future?
We did not take that factor into predicting into our forecast for this.
Okay.
But we can.
Yeah, go ahead.
Yes, but I believe something that we can still work on to help the model.
No doubt. Cool. All right. Thank you.
Okay, thank you very much, Albertus. Thank you, Team Packard, for that lovely presentation. Okay, now moving on to the next team Streamlit. Okay, you're already here. Your time starts now. Team Streamlit, Rogers Mugambi. You can start sharing your screen and on it. Your time has started.
Okay, good evening, everyone. Thank you for joining us today. My name is Rogers Mugambi, and I'm here with my team to present our project on a data-driven approach to content moderation, building a text classification model for offensive and hateful text. So our team consists of 12 highly skilled professionals who have been working tirelessly on this project for the last 4 weeks. With the rise of social media and other online platforms, there have been an increase in offensive and hateful language, causing harm to individuals and groups. Traditional methods of content moderation are time-consuming and costly. To address these challenges, machine learning models have been developed to automatically evaluate text for offensive or hateful content. Development of accurate and effective models require a large and diverse data set of labeled text samples and careful feature engineering and model selection. So therefore, our goal was to help in improve online safety and reduce the spread of harmful content. To do this, we have to develop a machine learning model that can accurately classify a given text as either offensive, hateful, or neutral. And the process will be training the model on a labeled data set of text, and the model should be able to generalize well to new and thin data. So our justification for this project is that the output of the project will enhance online safety, will enhance brand and reputation protection for businesses, and improve efficiency and reduce costs for businesses. So this is a process. It involved 4 working groups. The first working group was charged with machine learning development, machine learning modeling. The second one was development of the web app. The third one was data analysis. And the fourth one was to document all the processes that the team undertook. So the data was sourced from Kaggle, and the data had 6 features and 24,000 plus observations. The resulting data set was composed of 1 dependent variable and 1 independent variable. So the dependent variable was a multi-class dependent variable having 3 classes: offensive language, hate speech, and neither. So for the data analysis, this is just a warning. Content with offensive language and hate speech will be displayed. First of all, the class distribution, we can see that offensive language constitutes more than 25% of the data set. So this was something that we noted. And then, okay, on evaluation of the words per class, we found that offensive language also had the highest count of unique words, then followed by neither, then followed by hate speech. This concurs with the class distribution. So here is a word cloud for the most used words in the script that we evaluated. So moving on to modeling, we evaluated logistic regression, decision tree classifier, adable classifier, and long short-term memory. So we consider two matrices, F1 score and accuracy. But for us, our choosing of the models, we based this on the F1 score because it will provide it was more reliable for imbalanced data sets. And it also strikes a balance between recall and precision. So starting with accuracy, we find that Adabus, logistic regression, and random forest performs the best of the 5. Then moving on to the F1 score, for the class offensive language, random forest performs the best of the 5. For the class NASA, F1 score, Adabus cluster performs the best, but okay. And for the class H-speech, F1 score, decision tree cluster perform the best, but you'll realize for all the classes, the performance of the others are within range, close range to the best performing. So after modeling, the next the app that we developed, strategy that was used to deploy the model, we deployed all the 5 algorithms, and then each algorithm will provide an output. Then we use the output with the high frequency as a prediction of the text. So as an example, you can see the two texts here. So for the first offensive language detected is the one with the high frequency. So that's the predicted outcome. So the app was developed using Streamlit Python language with some HTML and CSS code, and we deployed through Streamlit Cloud. You can test the app by scanning this QR code or through this link. And thank you for your time. If you have any questions, you're welcome.
Thank you very much for that presentation. I'm moving on to our judges, Mr. Wale and Biodun. Do you have any questions, comments, or anything?
Yeah, I can go. I have just a quick question. What does class 1 represent again? That's neutral, right?
Class 1 was representing offensive language.
And then class 0.
Okay. Class 0.
Oh, okay. Yeah, the slides that you have on yeah, I was checking it and I think it's not updated, but the one you're showing now is updated. Okay. Yeah, okay, that sounds good. And then the other question is, for your models, how did you represent your text? What vector representation technique did you use?
So okay, so for the 4 model algorithms, random forest to Adabus, we use count vectorizer.
You use count vectorizers.
Yeah, you use count vectorizer.
Okay, and then what about for your LSTM?
Long short-term memory. There is tokenized that we use to break up. It comes with the algorithm so it handles.
So you just tokenized. Okay. Yeah, the reason why I asked is that I'm a little bit surprised that LSTM wasn't the best model, and that other classic machine learning models would perform better. So maybe it's probably because of the word representation technique. So if you use something like word embeddings and feed them into LSTM, it's very likely that it will outperform the rest, from what I can see. But I mean, this is really good. Everybody using social media. Everybody, there's already a proliferation of hate speech, and so trying to tackle them and detect them real time is very important. Ways to improve this project that I can think of is this is strictly data set in English. I would be interested in seeing something with an Afrocentric dimension to it. Things around detecting hate speech for African languages, Swahili, Yoruba, Igbo, or even languages where people code switch on social media, for example, right? If you can get data from Twitter, or you can get data from things around, like in Nigeria, for example, we have Nairaland, right? That will be sort of really nice, doing language modeling across trying to do language modeling for low resource languages, because we don't have a lot of research or a lot of work around that area. And a lot of people, maybe they tweet or they post on social media or other platform, code switching, using their languages. For example, if you're on Twitter, you go to check South African Twitter, a lot of the things that you see, even if they're chatting in English, before you know, it's going to change to Zulu, for example, or you see people, do a lot of things in with Swahili. So I will be interested to really see how these hold up when you have, code switching, or when you have low resource language. But overall, I think wonderful job. Thank you.
Yeah, thank you for that great recommendation. We'll find a way to apply it.
I would say that Wale pretty much took every single thing that I've written down. It was like we're sharing the same notepad. Great work overall. I mean, I'm very inspired when I see work like this, especially work that could create a niche for Africa, or can create a niche for Asia. Especially, there are so many languages that nobody knows about, and you don't even get to hear about these languages. So I would like for you all to consider, and more like restating what Wally has said, consider using, finding different languages and having more, be that data bank or data repository for languages that could be trained, such that you can start detecting hate. So outside of having passion for data science, I also have a strong background in cybersecurity, and one of the ways that big tech companies, especially when you go into social media platforms, try to prevent child abuse, offensive speech, hate speech, is by triggering APIs that generate that look for patterns in the words that are used for either child molestation or terrorism or any form of child abuse. If we don't know the languages, if we don't if we don't have models that can understand, like Yoruba or Hausa or Swahili or any of the other languages that exist, there really isn't a way for us to prevent it for the people that are in those countries. So it's an area where you all could even start a business around this, because it goes to my second point, which thankfully Wale hasn't mentioned yet, so I get to say this as a fresh idea. Look into how you could commercialize or monetize what you're building here into an API. The API economy is going to continue to grow and grow and grow. Who knows? Twitter could be getting an API from you all, because you've built such a robust database or such a robust model that's comprehensive enough to detect what hate speech or offensive speech looks like in Twitter. So that's my final comment. Overall, this is inspiring work. Blog about it and hold yourself accountable by saying that coming soon is Swahili models for hate speech, and then start that campaign. Or coming soon is Yoruba models for hate speech. And if you need bad words in Yoruba, I'm sure there's so many Yoruba people that can tell you, if you've got friends in that area. Overall, great work.
Thank you. I actually, yeah, I'll take it up with Swahili. Thank you.
Oh, sorry, am I audible?
Yes, Daniel, you are now.
Yes, you are.
All right, thank you very much. I think that's the end of the comments, right? So thank you.
Thank you.
You can stop sharing your screen. Next we have Team vSpy. Team vSpy, are you guys there?
Yeah.
Please start sharing your screen.
Can you guys see my screen?
Yes, we can.
Okay. Okay. So this is our capstone project, which is next word prediction, which is based on natural language processing. So which is done by Wispy team. And these are our team members. I really appreciate the hard work of our team members during the project development. So our problem statement was to predict the next word in a sequence. So what we did is we created a model in which we created a word which predicts the meaningful sentence. So this model should have high accuracy and low loss and able to generalize well to new unseen data. And it should be a user-friendly interface for making prediction. In this picture, you can see the example of how the real world application works. You can see that in your Android search field, when you type something, project team, you will get several recommendations below. And another example is Google autocomplete. When you type something in Google, you will get several recommendations in your search engine. So our approach was done in four steps. The first step was to collect the data from Kaggle, and our data set consists of 10 columns and 6,508 records. In the second step, what we did is we cleaned the data, we remove unwanted features that were not making any sense in our data. In the third, we implemented recurrent neural network, which is used in sequential data or time series data. This is a deep learning model, neural network, which is mainly used for natural language processing, speech recognition, and image captioning. In the first step, we visualize the relationship between epochs and accuracy. So let me show you this. This is our algorithm. In the first step, what we did is first we divide the sentence into word by using tokenization technique. In the second step, what we did is we selected the last word, okay, of a sentence. From there, then we find the probability of the last word by looking at the vocabulary data set. The data set consists of all the words, and in the final step, what we did is we predict the next word. So this is our dataset description, and I already told you that we use Kaggle as a platform, and we also use Medium article dataset as well. This is how our dataset looks like. We were having 10 columns in that, and our main feature was this title column because we have all the text present in this title column only. Let me show you this. Our model consists of N language model as well as a GRU based RNN model, which is a recurrent neural network.
Yeah, sorry, sorry to cut you short. Are you changing your deck? Because I cannot see. Is anyone seeing that or not?
Can you see my screen?
Oh, we can see.
Yeah. So it consists of 5 layers. First one is embedding layer. Second is two GRU layers.
You're sharing the wrong screen.
No.
Yeah, we can only see the title slide. That's it.
Yeah.
It's not changing.
Yeah, so there's a possibility you may have
now?
to
Oh, can you see?
Yeah, just close the slide and start again.
So if you have 2 monitors, maybe you want to.
Now can you see my slides?
Yes.
Yes. Yeah.
Hold on.
Yeah, just go back a little bit.
Yeah. So our model consists of 5 layers. First one is embedding layer, 2 GRU layers, 2 dense layer, and the final output layer. So let me show you the simple example of RNN neural network, which consists of input layer, hidden layers, and output layer. And I will show you how n-gram model works. So if we type n is equals to 1, it consists of unigram, which represents unigram. So it represents this as a first word, is as a second, a as a third, and sentence. When we use n is equals to 2, which represents bigram, it considered this is as a first uh, first word, first cell, and is a second cell, and a sentence is the third cell. In the trigrams, we have 3 words at a time. So these are our result of the trained model, which has highest accuracy, which is 0.9961. Log loss was 0.0094. High degree of accuracy was found in our data set. And the visualization, let me show you the visualization. I will explain it in you more detail. So on the y-axis, we have accuracy, and on the x-axis, we have epochs. So the higher the accuracy, the more the epochs. And on figure B, we have loss. So if the loss during the optimization problem happens, so what happens is if the losses becomes less, the epochs also increases. So our model was deployed using a Flask library. We use HTML, CSS, and JavaScript for deploying the model. So this is a prototype of our model, how it looks, and this is the resulting output. Yeah, if I type here a beginner guide to, and if I type the 3 words to predict, next 3 words to predict, it is going to predict the next 3 words, a beginner's guide to word embedding, and that's it. Thank you. Let me just show you a deployment part. Hold on. This is our mod. This is our simple application. So if I type here a beginner's guide to, and if I type next 2 words to predict and click on predict, so it's going to predict the next 2 words. Similarly, if you try some different word here, how to use ggplot2 and predict the next 2 words, is going to predict the next 2 words. How to use ggplot2 in Python. That's it. Thank you.
Hello, sorry, please, am I audible?
Yeah.
All right, great. Charles, and then Wally, please. Charles.
Yeah, I think this is very interesting, and you see applications of these in mobile phones and cell phones where they can auto predict what you're going to type. But yeah, this is really impressive. But my question for you around this is like, how do you adapt your model to deal with OOV, out of vocabulary words that are not like commonly available in your training data sets? Do you have a way of feeding back what you've learned, or what the new things that you're picking up? You're feeding it back to the model to improve it. Then the other thing, my other question after that will be the context understanding. Words mean different things in different contexts. Is your model or what you've done context aware, or is there any way you can improve it if that's not the case to be context aware? So 2 questions, the OOV and the context understanding. If you can quickly answer that. Thank you.
Okay. So we can use our model in predicting the next word. The good example is the chat GPT. So when you type something there, it will give you a lot of suggestions. So it is based on natural language processing, and we used a feed-forward neural network to build a model, and we use epochs. The more the epochs, the higher the accuracy we have in our model.
Okay. What about contextual understanding? The words mean different things in different ways. Like Wale was mentioning something about code switching earlier. For us that speak multiple languages and you're mixing words together, how does that affect the way your model prediction comes out for somebody that is that speaks in multiple languages? And how do you contextually understand what they're typing over time? Are you on mute? Hello?
Hello, can you hear me?
Yeah, I can hear you now.
Hello,
Mhm.
hello.
Yeah, we can hear you.
Your voice is breaking too much.
Oh, so what I was asking is a contextual understanding of the
Hello,
work.
sorry, am I audible?
Yeah, you're audible. Yeah. Are you there? Can you still hear me?
Yeah, I can hear you, but
Yeah,
your
you
voice is
said,
breaking.
yeah, I was asking contextual understanding. How do you predict the next word in a sentence based on the context? Do you understand the context of that word in the sentence? Will your model be able to like
So
understand?
actually, the model is already consists those 10 sentences in our data set, right? So based on that, it predicts the next word. So there is a huge amount of data which consists of lot of text,
Mhm.
and depending upon the data, it predicts the next word.
Okay, all right.
So it cannot do it naturally. By its names, it doesn't mean that natural language processing. It doesn't mean that it does naturally by own. So we need to give the data, and then it predicts the next word.
Okay, all right. Cool, thank you.
Yeah, thanks for the presentation. I think I have like two comments. The first one is something that I would like to see, for example, is analyzing or doing sort of additional testing on your model using like other baseline. For example, you can input the same word into Google search and see what the output is, and then use it to compare with the results that you have, right? That would be nice, because just typing something to Google to give you a next word prediction. And I think this is in addition to also thinking about what Bill mentioned around out of vocabulary words and then sort of contextual understanding. So I think those would definitely improve this project. And then the other one is that, I mean, I know using RNN and sort of stacking your layers, they're really, really good. But in the last 3 to 4 years, or even in the last 2 years, we've seen the proliferation of large language models, like things around maybe BERT. And BERT actually worked around predicting the next word and also sort of masking some of the words in a sentence. So I would really like to see, I think BERT would definitely improve the models. If you can fine tune a BERT model to check, to sort of benchmark against what you have right now, I think that would definitely improve the methodology. Yeah, but overall, nice one. Thanks.
Thank you. Thank you.
Yeah.
Hello, can you guys hear me, please?
Yes, we can hear you, Daniel.
Yes.
All right. Sorry, I have terrible network. That's why I keep trying to confirm. So, thank you very much, Charles and Wally, for that comment. Indeed, we have come to the end of our presentations for today. It's been nothing short of wonderful, sitting back and listening to the work that has been done in the various teams. I'm sure everyone will agree with me that this has been quite the insightful and educating experience. Any final words for our interns regarding their performances so far, perhaps recommendations for the future and anything they can do on their projects, Charles?
Yeah, I mean, I think a great job overall from everyone. I think one thing you want to do is to just keep the momentum up and keep going. The more you know, the more you discover you don't know. So if that guides you, then you always want to keep improving on yourself and making things a lot more better. So I'll just echo what Bjorn and Wiley have always been saying, like expand on your body of work, publish whatever you've worked on, try to contribute back to the open source community. They've really helped you. And I think if you're doing that, it helps you build your network and people that will be interested in working with you potentially along the way. And if you have any questions or if you have any comments based on what we've said, you can always reach out to us or follow up, and I will be glad to help you further. Yeah. So overall, great job, and I wish you guys great success down the road.
Thank you very much, Charles. Does Wally have anything to say?
No.
Or Beardo? Okay. Beardo?
Yeah. Can you hear me?
Oh, hello?
Can you hear me?
Yes, I can, sorry.
Okay. Yeah. Not a lot. I think Charles actually just said a lot of the things that I would also recommend. You guys should remember that it's a marathon, not a sprint. So you can always improve on some of the things that you've done or presented today. You can try new approach. Maybe much better analysis. Have a write up on Medium and just keep working. Yeah.
All right, thank you, Wally. Beardo,
Well,
do you have
great
anything
job.
to? Okay.
Yes, I'll just close by saying great job to everyone. It's been a huge privilege getting to see what you all have done, and in my opinion, the Amway internship continues to get better every single cohort that you all have. The maturity in the presentation that you all have presented, or you all have gone through, has been like it's been evident. My ask is, as you're solving problems, continue to look for ways to solve problems that are happening in your own community. I mean, that you can solve global problems, but you'd be surprised that the problems that are happening in your own community may be problems that are unknown. Like Wale and Charles, that I've mentioned, contribute back to the open source community that's pretty much giving you a lot of the tools that you're using today. A lot of companies and a lot of startups are beginning to invest in AI companies. And I would argue that a lot of what you're doing right now are very AI driven. For what it's worth, AI is going to be like the next foray for everything, literally everything that's going to be powered in the world. So I hope you're encouraged that you're in like the cutting edge, you're at the forefront of where the world is being shaped by. Don't stop, keep giving, keep contributing, and keep solving problems. Leverage API communities too. A lot of what you're creating right now could be converted into an API. The next big company starting in Africa or India or any part of the EMEA or Asia Pacific region could be coming from what you guys are doing currently. Find opportunities to contribute and collaborate with others. Don't see like the world is already global because of the internet. So when you're posting articles, ask for collaborators. You might be surprised your collaborator might be a big company. Your collaborator might be someone else who's doing something niche. It is in combining ideas that people create even bigger ideas that turn out to be revolutionary. So keep up the great work and let us know how we can continue to help you all.
All right, thank you very much for that, Beardo. At this point, I'd like to say a big thank you to all our presenters, teams, and judges, Charles, Beardo, and Wally, for a successful session. Myself and the rest of the Amoye team are honored to have hosted you on what was the climax of a rather intense 4-month journey in the field of data science. We can't wait to see you soar in your chosen fields. Please take note of the following. Information regarding the results of the presentation, as well as any other announcements, will be shared with you via Slack and your mails. So please be on the lookout for that. On that note, it's a goodbye from me. Do enjoy the rest of your weekend. Thank you, everybody.